Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today, guys, we're going to wrap up Chapter 5, and we're going to put all of these factoring techniques into actual use. And we're going to learn how to solve polynomial equations by factoring. And to be exact, we're going to learn how to solve quadratic equations. Now, let's go back in time a little bit, okay? Hopefully, you guys remember what a linear equation is. Linear function. Our equation is in the form of y equals mx plus b. If you guys remember, the m is the slope. I don't know if you guys remember that. I hope you do. Okay, that's the slope. What was the b, guys? The y-intercept. Very good. Okay. Y is the dependent variable. X is the independent variable. M is the slope. And b is the y-intercept. Guys, what is the power of x here? Yeah, when you don't see a power, remember it's an invisible one. So notice that the degree of this linear function of this polynomial is 1. When the degree is 1, that lets you know that you have one possible solution. Okay? That's what the degree tells you. That's why recognizing the degree of a polynomial is so important, because the degree tells you how many solutions you have. Okay? Now, what is a solution? Well, remember, a solution is the point that goes through the x-axis. So in a linear function like this, which renders straight lines, those are my solutions right there. What's the solution for this green line here? There is no solution. No, it's not 0. If it was 0, it'd be going through 0. This is, no, that's undefined would be the slope, but that's not an undefined slope. That's a 0 slope. An undefined slope is a line that goes up and down. And that's why this isn't here, because if you read, we're talking about linear functions. And this is not a function because there are more than one y value for the same x value. So that's why I did not put the x equals equation, because that is not a function. But functions, okay, have solutions where they go through the x-axis. So since a linear function has a degree of 1, we know it's only going to go through one spot on the x-axis if it goes through it at all. And that's going to be the solution. So again, the degree determines how many solutions you're going to have. Now, a quadratic function are in the form of y equals ax squared plus bx plus c. Let me just let you know right now, we have not graphed these yet. I give you my word of honor. We're going to learn how to graph it. But a lot of times, teachers teach the students how to factor, how to use what we learned today, which is called the zero product property. But there's no real context to it. They just tell the kids, all right, you solve it like this, x equals 5 and 2. Okay, that's the answer, bye-bye. Okay, but why? What does that x mean? Where is it going? Where is it coming from? What are we going to do with that information? And that's what I want to really focus on today. The actual math of today's lesson is a joke. I want to make sure you understand what we're finding. So, that being said, when you have a quadratic function, y still equals the dependent variable. X is still the independent variable. A and B are coefficients. Hopefully we remember our vocabulary. Coefficients are the numbers being multiplied in front of a variable. And C is the y-intercept. Now, what is the degree of this function? What is the degree of a quadratic? 2. Very good. Notice that the degree of the polynomial function is 2. So that lets you know, guys, that you can have up to 2 solutions for a quadratic function. Now, are you always going to have 2 solutions? No. You could have 1 solution. You could have no solutions. You could have 2 real solutions. You could have 2 non-real solutions, or in other words, complex solutions. We haven't gotten there yet. We're going to. But just so you understand, the degree tells you how many solutions can I have. And I can have up to 2 solutions here. Now, let's look at what a quadratic function looks like so we could put this lesson really all together right now. A quadratic function renders parabolas. Parabolas are U-shaped graph, my brothers, such as the two that I have right here in front of you, okay? And the points at which the parabola crosses the x-axis are the solutions of the quadratic function. So in other words, the x-intercepts are the solutions of the quadratic function. So when we look at these two functions, you got this guy and this guy right here. Those guys are my solutions. Why, Mr. Morrow? Because those are the x-intercepts. And when we're looking for solutions of any polynomial function, the solution is the point at which the graph crosses the x-axis. If it does not cross the x-axis, there's no solution. Yes, sir, my brother. In this lesson, we're looking for the solutions, and we're going to find them by factoring. Thank you, my brother. We can find them by graphing. We can find them by completing the square. We can find them by putting them into the quadratic formula. But we're not there yet. The only skill we have right now is factoring. So we're going to learn how to find these two solutions by factoring. If I look at the graph on my right, the graph goes through -6 and through 4. So my solutions here are x equals -6 and 4. Again, why are those the solutions? Because those are the points that the graph passes on the x-axis. Does that concept make sense, guys? That is what we're looking for. We're looking for the x-intercepts, basically. We're looking for the solutions, which are the x values that the graph crosses on the x-axis. You feel me here, gentlemen? All right, brothers. So, that being said, sometimes we can find the solutions of quadratic functions by factoring and using the zero product property. I say sometimes because maybe it's not factorable. In that case, we're going to use the skill of completing the square or the quadratic formula, but we're not there yet. So the zero product property, last thing I got to teach you before we put it all together today. For any real number a and b, if a times b equals 0, then a and or b must equal 0. So when we factor a trinomial, are we not left with two binomials just like here? Well, guys, we're going to use the zero product property. What we're doing is we're setting the y value, this used to be y, we're setting that to 0. Why are we setting that to 0? Because we're trying to find the x-intercept. And if you remember, the x-intercept is the x value on the x-axis when y is 0. Thank you for that. Good job. That's what we're looking for because x-intercepts are the solutions. Is this trying to make sense, guys? So I'm setting y equal to 0, and I'm literally going to set, this is my a times this is my b. Whenever I have a product of two values, whether they be polynomials that are complicated or easy, if I have a product that equals 0, each factor of that product must be set equal to 0. So therefore, x plus 3 must be set equal to 0, and x plus 2 must be equal to 0. So in this particular case, x equals -3 and -2. Morrow, that's fantastic, but what does that mean to us? Let me explain what that means to you. That means that on a graph at -3 and at -2, there's a quadratic function that is crossing through there. That is not an accurate graph. This vertex I made up. I didn't show you where it went through the y-axis. But what I am showing you is the representation of what we're finding today. We found here that x equals -3 and -2. What we know for a fact is that we have a quadratic function going through those two exact points. Does that make sense, guys? I promise you, I'm going to show you how to find this thing, which is called a vertex. I'm going to show you how they're symmetrical. I'm going to show you all of that. But right now, I'm just focused on factoring and zero product property and what that answer really means. We good? All right, let's crank it out. Now it's easy. Excuse me. Okay, so what are the solutions of the equation? I already factored it out for you. This is what you're left with. So when I am left with a product that is set equal to 0, what must I do to every single factor of that product? Yes, sir. Thank you, my brother. So what do I got? So I got 4x plus 1 equals 0, and x minus 2 equals 0. So let's solve for both of them. Subtract 1, divide by 4, x equals -1/4, and x equals also 2. You do not have to do this part, guys. But as a teacher, I want to make sure you understand what is it that I just found. What I just found was the fact that you have a quadratic function here. How do you know it's quadratic, Morrow? Because I had two solutions, okay? And one of the solutions is going through -1/4, and the other one is at 2, and that means that I have a graph going something like that. Most important part, the solutions. It intersected the x-axis at 2 and -1/4. Does that make sense? Everyone's clear with this? You good, my man? May I continue? Thank you. All right, boys. Let's do this then. Easy peasy. I already set this up for you, the first part, just so you can get used to working with the zero product property. So I've already factored this up for you. So I want fire right now. I want fire. What are my solutions here? X equals -1 and 5. For anyone that's still like, what did he do? I had a product. This is my A and this is my B. Whenever I have the product being set equal to 0, I'm going to set each individual product equal to 0. So therefore, x equals -1, and x also equals 5. Yes, sir, my brother. Why is the one negative? Right here, my man. Check it out. This guy right here. If I have x plus 1 has to be set equal to 0, how do I solve for x, my brother? How do I get rid of a +1? You subtract 1 to both sides. That's exactly right. So x equals -1. Thank you, my brother. Next, what are my solutions here? N will equal +2/7, yes? No, 4/5, guys. Guys, don't be a hero. If you can't do it in your head, there's no shame to that. You have 7n minus 2 equals 0. You got to add 2 to both sides. 7n equals 2, divide by 7. That's how I got my 2 7s. And I've got 5n minus 4 equals 0. I can add 4 to both sides. And I've got 5n equals 4, divide by 5, n equals 4/5. You with me here, boys? And again, I'm not going to draw it out, but what does that mean? What does that tell you right now? Yes, sir. That you have a parabola that's going through the x-axis at what 2 points? At 2 7s and at 4/5. Guys, I only had one person answer that question. What don't you understand so I can help you? I want to walk out of here knowing that I did my best. Only one person answered that question. What is so difficult about what I just asked? This represents the points on the x-axis that this particular graph happened to pass through. What don't you see, sir? You do not have to find the parabola, no. But isn't it better to know what you're finding instead of just saying a random, hey, this x equals negative 1 and 5. Why, Mr. Morrow? Oh, whatever. It's just two values that you want to. I don't want to teach like that. I want to teach that you know what it is that you're finding. You found the 2 points right here that this parabola happened to go through. I repeat, you do not have to sketch the graph. I am just putting this part right here so you could understand what it is that this means. Does it make sense to everybody? Promise. Okay, let's continue. All right, guys, I'm already set up for me here. So x equals negative 1/2 and negative 14. Very good. Just for giggles, what does that mean? What does x equals negative 1/2 and negative 14 mean? What does it mean, my brothers? Yes, sir. Very good, my man. Excellent job. This means that the graph will be passing through negative 14 and negative 1/2. That graph is not accurate, but I don't care about that. What I want to drive home today is that you're finding the solutions, the points that the parabola crosses the x-axis. Does that make sense, my brothers? Okay, I don't want to bore you. I just want to make sure you got this good. Yes, sir. Okay, in this particular case, the question was, why are the parabolas always pointing upwards? These are particularly positive because 2x times x is going to be 2x squared. If this coefficient is negative, that's when they go downwards. But again, we'll talk about graphing later. Like I said, and anyone watching out there in the internet world, these graphs are not accurate at all. The only accurate thing about this graph is that it happens to be going through negative 14 and negative 1/2. But that is not an accurate graph. That is not how you graph. We don't know how to graph yet. We're going to learn. You with me? Thank you. All right, what are my solutions here, brothers, for D? Negative 3/2 and 4. Very good. So that means that this parabola goes through the x equals 4 and the x equals negative 3/2. Excellent. Okay, now let's put it all together. This is where we factor, use zero product property, and we find the solution. Which again, I know I'm a broken record today, like most days, but the solution are the points on the x-axis through which the graph passes. You feel me? Let's rock and roll. All right, 1 times 1 is 15, but 1 added together is 8. So I got x plus 3 and x plus 5. I've got a product that's set equal to 0, so I'm going to use my zero product property. X plus 3 equals 0, x plus 5 equals 0. I already heard the answer. Thank you. You're amazing. X equals negative 3 and x equals negative 5. I promise this will be the last time I do this. That means that the graph passes through negative 5 and negative 3, and that means that those are the solutions of this quadratic. That is the last time I'll graph it, I promise. But everybody understands this. No one has any questions. We all got this. Yes. All right, now let's fly. What times what? Okay, someone asked, do we have to graph the parabola? No. It is a parabola, yes. Parabola, and it's called parabola. But again, you do not have to graph it, guys. That's just for teaching. Okay, so let's factor. What times what? You got it. P plus 5, P minus 4 equals 0. Zero product property. P is going to equal negative 5 and 4. Boom. What times what is negative 14? But when added together is negative 5. M minus 7 and M plus 2. Zero product property. What does M equal? What are my solutions here? 7 and negative 2. Bingo. Yes, sir. If it has a GCF, you factor like normal, like always. Always. And we're going to get to that. How about here? Do I have a GCF that I can factor out? No, I'm out of luck. So I got to do my cubic method. So 2x, 2x, 2 times 18 is 36, positive. What times what is positive 36, but when I add together is negative 15, y'all? No? 12 and 3, thank you. Negative 12, negative 3, imaginary factor of a 2. So I've got x minus 6 times 2x minus 3 equals 0. 0 product property, x will equal 6 and 3 halves, guys. Okay, I had a little, people got stuck there. Why? You got to set both factors equal to 0. So you add 6 to both sides, so x equals 6. You add 3 to both sides, 2x equals 3, and then divide by 2. So x equals 3 halves. Does everyone see that? Okay. Now, how about this bad boy here? Now I'm not setting it up perfectly beautiful now. I don't have a trinomial yet. But what can I do to create a trinomial? Yes, sir. How do I bring over a positive 18? My man. Good job, kid. So I'm going to subtract 18 to both sides. So I've got 4x minus 21x minus 18 equals 0. Can I take out a GCF? No, unfortunately not. So I'm going to go ahead and I'm going to have to factor. Cubic method. 4x, 4x. 4 times negative 18 gives me a new c of negative 72. What times what is negative 72, but when added together it's negative 21. I'll pause while you guys think about it. That was a very quick job. Well done. And it is negative 24 and positive 3 because negative 24 times 3 is negative 72. Negative 24 plus 3 is negative 21. Imaginary factor of 4. So I've got x minus 6 times 4x plus 3 equals 0. I got to set this using the 0 product property to 0. So what does x equal here? X equals 6 and negative 3/4. Beautiful. Beautiful. Very good. Okay. How about this next one? 1 times 1 is negative 54, but when added together is 3. Excellent. Who's positive, though? You said 6 and 9. That's beautiful. Good. Positive 9, negative 6. 0 product property. X is going to equal negative 9 and positive 6. Bingo, bango, bongo. Excellent. Well done. Well done. No, thank you, guys. Awesome. Okay, what do I got to do here because it's not a trinomial yet? Yes, sir. You darn right. You're going to add 49 because I got to make a trinomial. So I've got x squared plus 14x plus 49. Can anyone recognize something really special about this? Yes, sir? Come again? What about 7, my man? Now you can't factor this by 7, no. But you're close. There's something to do there. Is this a perfect square, gentlemen? What is the square root of that? Is this a perfect square, gentlemen? What is square root of 49? What's 2 times x times 7? 14. Is this a perfect square binomial or trinomial? So that's squared equals 0. Now, what does squared mean to you? You're multiplying it times itself, right? So technically speaking, this is x plus 7 equals 0. Technically speaking, x equals negative 7 and negative 7. Does it make sense to repeat it twice? No. So when you have what's called a repeated solution, you just put it once. Now, You may say, oh, hold on, Moro. Now you're changing the game. Before you were showing us there was two solutions. Now there's only one solution. What did I tell you about the degree? That there could be up to two solutions. So in this particular case, guess what, guys? Here's my -7. In this particular case, my graph is going like this. And it's only hitting it where? At 1.1 time. So when you have two solutions, it went through 2x points. When you have one solution, it goes through 1x point. When you have no solution, guys, not to be sarcastic, but it goes through no x point. It doesn't go through the x-axis. Does that make sense, gentlemen? Now, how about this one? You know what I want to do first, though? Because I want to make sure I address the question that my boy had asked. Make that a 4. Make that a 42. And make that a 72, guys. I know, I obviously multiplied 2. I know. But the reason I want to do this is for this. GCF. Let's talk about the GCF because it's important. I can take a GCF here out of 2, then be left with my 2x squared minus 21x minus 36. Now I'm going to have to cube and method it. The 2, remember, I'm going to erase this green graph. Is that cool, guys? Okay, so I'm going to have to cube and method it. 2x, 2 times -36 is -72. 1 times 1 is -72, but when I add it together is 21. We did that one already. -24, +3, imaginary factor. So I got 2 times x minus 12 times 2x plus 3. And this all equals 0. Now, according to the zero product property, when you have products that equal 0, every single product must be set equal to 0. So that includes the 2. But let me show you what happens. So you gotta set 2 equal to 0. You gotta set x minus 12 equal to 0. And you gotta set 2x plus 3 equal to 0. Now, guys, can 2 ever equal 0? So even though you're following the product property, that's not a solution. What are my solutions here? 12 and -3/2. Does that make sense? Does that answer your question? Does that help you now, my man, with the GCF bubble? Thank you, brother. Man, look at that. Perfection. Thank you so very much, guys. Hope you had a great lesson. God bless you, and I hope you learned a lot. Bye-bye.